Alrighty folks, welcome back. So in this video we're just going to talk a little bit about function notation, why it's useful, and how to read it. I guess how to read it first and then why it's useful at the end. So here's an example of not using function notation, and I'm going to draw a little function machine here just because I like to draw them. And I'll say y equals 5x plus 3. And typically we use x to represent the input. So x is the input, and that gets thrown in the top, and out comes the y, which is again our output. And so let's suppose I want to throw in x equals 5 for the input. Okay, so that just means you substitute x equals 5 in here, so this now says 5 times 5 plus 3. We solve that, out comes the output, in this case y equals 28. And so here's how you would say that then. You're kind of explaining everything that we just did. I would say when I input x equals 5 into y equals 5x plus 3, the output is y equals 28. It's a very long sentence to say. Here's how we say it faster, right? So this might look familiar from Algebra 1. We would say, well, what's the equation we're looking at? Well, we're looking at this equation, and you just replace y with, again, f of x. This is how you say that, f of x. Oops. But really, that just means y. It's the output. Equals 5x plus 3. And then we would say that f of, and then what was the input? Because remember, all x is the input. And so, well, when I threw in 5, I got 28. This string of symbols right here in green and this sentence in green are the exact same thing. So that's why it's helpful, because one, it speeds up the process. But the other reason it's helpful is because we can actually use this to distinguish between two different equations. Check this out. So if I now said, actually we'll just keep it over here, new example down here. Let's suppose I have two machines here, y equals, I'll just keep one the same, 5x plus 3. This one over here, let's say y equals x squared. And so these are our function machines. Both of their inputs are x and so on. Let's suppose someone asks you the question like this. What is y when x equals 3? Actually, let's not use 3. Let's use negative 6. Well, you would not really be able to answer the question because you have no idea which one they're talking about. But if I instead changed it, instead of saying y and started talking about, let's say, g of x and f of x, then you can be really, really clear. So instead of needing to say this, I could just say, what is f of negative 6? Or I could say, what is g of, I don't know, 2? Because now you know exactly which function you're supposed to use. Right, so this one, f of negative 6, that would just be, 5 times negative 6 plus 3, which would be what, negative 27? And then g of 2, well, that would just equal, g of 2 is equal to 2 squared, which is 4. Okay, another problem that you might see is something like this, where you would have f of x equals 30. And now, as it stands, it kind of doesn't look like there's actually being you're not actually being asked a question. Let's think about what this it means is that the input x, which you don't know, gives you an output of 30. Again, this 30 is the output. So really all this is asking you is if y is 30, the thing that come out was 30, what was the input that went in? That's not so bad, because now we can just know, instead of substituting 30 in for x, like we did previously, we're now substituting 30 in for y. Except it's not y, it's called f of x. Remember, this object, that's just one object. It's not f times x, remember that. So remember, we said that f of x, whatever goes in, the output is 5 times that input plus 3. And so this output just replaces this now. And so I have 30 equals 5x plus 3. We'll take away 3 from both sides, get 27 equals 5x. And this tells us that 27 over 5 was the input. So that was just a little refresher on function notation, how to read it, how to interpret it, and how to deal with it. I actually did want to bring up one more thing, because this comes up often, and it's actually some problems. So let's pretend still our f of x is the same one it was, 5x plus 3. But now you're being asked, like, what is f of a plus 3, pretend? Well, just think about, again, what this means. This just means the input. So x is really just a stand-in for whatever input is. And so really what this equation says, and then we usually just use x because it makes writing things out faster, this really just means that f of, again, whatever input goes in, you just take 5, multiply it by that input, and then add 3. It's just now that we have this expression here, our input is a plus 3. And so in this case, it would just be 5 times a plus 3, because again, that is our input. And then plus 3 again. We could do all kinds of stuff like this. For example, I could do f of smiley face. All that would mean is, well, my input's smiley face now, so I have 5 times smiley face plus 3, whatever that is.